different size. Now, in my example here, one of the things about similar triangles is that all matching angles are equal. So the two top angles would be equal, they're matching, so angle A is equal to angle D. The corner angles here would be equal, so angle B equals angle E. And the corner angles right here on the other side here on the right, so that means angle C and angle F would be equal. So that means if you have all the angles are equal and they match up, your shape is the same size, and so you have similar triangles, or your shape is the same. Now the other two, and this is going to be a huge for us, is the second thing, because I said three things are true about similar triangles, is that the ratios of matching sides are equal. All right, now ratios, this is something that's going to come up quite a bit in this well, not quite a bit, but it is going to come up in this trigonometry unit, is a ratio can be written a couple of ways. It can be written as a ratio and as a fraction. All right, so for example, again, I'm going to draw a couple of triangles here. Let's see, we have a triangle just like this, angle A there, or side corner A, B, and C. And then I've got a smaller triangle, again, same shape because they are similar. And I'm going to go with D, E, and F. And so what that means, the ratio of matching sides are equal, is that when we compare two sides, for example, if I compare side A and B and its corresponding side D and E, I can actually write that as a fraction, where I take side A, B, all right, so that's a side from A to B, divided by, that's a whole ratio because I'm going to express it as a fraction, DE, that ratio is equal to, say if I compared, let's see here, B to C, and I divide it by its matching side, which would be E to F. Now there is three ratios because there's three sides to a triangle. So that ratio would also be equal to if I went from C to A and I divided by F to D. So what I did was, if I take a side from the big triangle and I divide it by the side of the matching side of the little triangle, it would be equal no matter which side you pick. The number would be the same. The ratio would be the same. Or in this case, the fraction would be the same. All right. So again, this is something we're going to do in a couple of examples. But again, if you take a side from the big triangle, divide it by the matching side of the little triangle, no matter which sides you pick, as long as you get the matching sides, you're going to get the same number. All right. So that is a key thing. And again, we're going to use that. Now I said there's three things. All right, so we'll get to that third thing. I have to run out of room here. All right, now the third property that is true about similar triangles is that, now this is a long wordy statement, but again, I'm going to draw it out here, is that, get that dry. The ratio, again, a ratio, so we're going to be talking about fractions. The ratio of the areas is equal to the square. So we're going to be squaring something of 1. Of the ratios. So we got a fraction we're going to be doing of matching sides. All right, so what the heck does that mean, right? So again, I'm going to draw a diagram here. That's always makes it easier to figure out what I'm actually talking about here. So the ratio of one of the areas is equal to the square of one of the ratios of the matching sides. And so, for example, again, I'm going to draw ourselves a triangle here. So I got to have a big one here. That's triangle A, B, C. And again, you're gonna have a similar triangle, same shape, different size. All right, so we have, whoops, D, E, F. All right, now if I take the ratio of the areas, so I'm going to take the area of the big triangle. So area of triangle ABC, because I'm doing a ratio fraction, I'm going to do divided by the area of triangle DEF. So that is the ratio of the areas, right? Take the big area divided by the little area. Or you could do it the other way. But here's the key is the bigs are either all on the top or all on the bottom. Got to pick one or the other. Can't mix them up. All right, now that is equal to the square of one of the ratios of the matching sides. Now that's something we just talked about, the matching sides. So that could be equal to, say, the ratio if I compare A to B divided by D to E. So AB divided by D to E. But again, it's the square of that ratio. There we go. All right, so we got the, again, the big triangle information's on the top, little triangles on the bottom. But it can also work for any of the side ratios. So we got three sides, we got three ratios, and running a bit of a room here. But let's see, I could put compare BC to EF. Squared. Or the third side, so we have C to A, F to D. So CA on the top here, F to D on the bottom. And again, that would be squared. So those are our three properties of similar triangles. All right, so now we're going to look at how do we use these properties, right? How do they show up? All right, so I get to example 1. All right, are the following, I don't have time to write it out, are the following triangles similar? So let's see here. A. So again, I'm going to use triangle A, B, and C. All right, here I got another triangle. Again, I'm going to go with D, E, F. Keep it. Now, it's going to be tough to see this, hopefully. There's a 70-degree angle there, a 50 here. And I have a 70 up here. And a 60 in that corner. I'm writing it a little bit big so you can see it on the camera there. All right. And I want to look at, are these triangles similar? And this comes down to, because I have the angles, it's the only property where I know the angles is property 1 there. Are the angles all equal? So I match them up here. Well, angle A and angle D are equal. But I don't know about B and E, and I don't know about C and F because I don't have all the information here. Now, this is a little grade 9 math coming at you. Does anybody remember how what all the angles inside a triangle add up to?
180.
180, right? So I can actually figure out here in the center what we got. And so if I add up 70 and 50, that's a total of 120. 120. And so if I know that all of them add up to 180, I can subtract the two numbers, and well, 180 minus 20 is 60. And so I could do the same thing for our second triangle here, in which case it is also 50. And so because all the angles are matching up, they are similar triangles. All right, let's see here. B. I want to see if these triangles are similar. So a little bit different situation here. Again, I'm going to try to draw this as best I can. We have triangle A, B, and C. And I've got, I got some measurements on there. I have an 8, a 5, and a 12. So I got the side lengths here. And now I got the second triangle, which again I'm going to call DEF. All right, and I know that this is 4, 6, and 2.5 right there. All right, so I want to see if there are similar triangles. Now again, because if they are similar triangles, this comes down to property number 2, where we looked at the ratio of the matching side lengths are equal. So here's how I'm going to prove that, or use that property to show that they are similar. I'm going to look at my matching sides here, where I have the side A to B and D to E. Now, if I calculate that or look at that ratio, that fraction, so I have, again, I'm looking at A to B divided by D to E, because those are matching sides. And again, I'm going to use my triangle on the left is going to be on the top, my triangle on the bottom, information is going to be on the bottom, or on the right is going to be on the bottom. And so A to B is 8, divided by D to E, which is 4. Well, 8 divided by 4 is 2. So one of my side ratios is 2. Now, if they're similar triangles, that should happen for every side ratio that I calculate, the next 2, because there's only 3 sides, right? And so I'm going to do the bottom here. BC divided by EF. So I got BC divided by DF. And so I take my 5 and I divide it by my 2.5. 5 divided by 2.5 is also 2. All right, so 2 out of 3 so far. If I go 3 for 3, it's a similar triangle. And so I take my, and I don't have room here, but to write it, but look at this. A to C divided by D to E, or D to F, sorry. That's going to be 12 divided by 6. And guess what? It is 2. And so because the matching ratios of the sides are all the same number, it doesn't have to be 2, we now have those are similar triangles. All right, so there's 2 ways to prove that we have similar triangles. All right, now, that's 2 of the properties that I just used. Let's see example number 2 here. All right, so example number 2. All right, now if triangle ABC, and here's a little notation for you, a little squiggly line. That squiggly line means similar to. It's easier to write a nice squiggly line than similar to. So if these 2 triangles are similar, so I'm saying they are similar, find X. All right, so here we go. We have, surprise, surprise, triangle ABC. All right, and I'm going to say that there's X right there. And I'm also going to say that the area is 64 cubic meters, or sorry, area, meters squared. Sorry, I don't have volume. All right, now I have another triangle here, which is triangle DEF. All right, and I'm going to tell you this side has a length of 10, so from D to E. And I'm going to tell you that this area here for this triangle is 16 meters squared. All right, now, how does all this information help us out to find X? Well, I'm going to use my third property because I have an area of the triangles. I know that they're similar, and I'm trying to solve a side X. Now, the property number 3 says if you take the ratio of the areas, so take one area divided by the other, it is going to be equal to one of the side ratios squared. So what I can look at is I'm going to take my triangle on the left, the area, and divide it by the triangle on the right area. So 64 divided by 16. That is my area ratio. It is going to be equal to one of my side ratios squared. Now I only have, or I only know one side, all right? And that one side, matching sides that I know about, is an X and a 10. Now again, because my triangle on the left is on the top, the X is going to go on the top. The 10, because it's on the triangle on the right, it's on the bottom. All right, now I have an equation where I can solve for x. So here's how I'm going to do that. First off, I'm going to fix this fraction. Now this is something we did earlier with power laws. Expanded power rule. If you have a fraction and it's to an exponent, the exponent gets applied to both the top and the bottom. So I have an x squared, and I also have to square the 10. Well, 10 squared is 100. Now this is something that's going to happen all this unit. I'm solving, I got a fraction equaling a fraction. Does anybody know how to solve a fraction equaling a fraction? How to make it easier? Not just solve it, but to make it easier. There's a real good trick, and we're going to use it the rest of the quadrimester. Anybody have any ideas?
Is it to make it to a decimal?
No, that would kind of work, but not at the same time, not really. Here's something that works. Like I said, we're going to do this. We are going to cross multiply. That's how you get rid of fractions, when you have a fraction equaling a fraction. So I'm going to go 16 times x squared, and I'm going to go 64 times 100. All right, so I got, let's go with 16 times x squared. All right, then I go 64 times 100. Well, I get 6,400. Now I'm going to divide both sides, because I want to get x by itself here. I'm going to divide both sides by 16. And so now I have x squared is equal to, well, I'm going to use my calculator here, 6,400 divided by 16. 6,400 divided by 16. I get 400. And then, of course, when I have x squared, I take the square root of both sides. I take the square root of 400. Now, our last unit, you got plus or minus. But the minus doesn't make any sense this time because we're talking about a length. So when I take the square root of 400, you don't have to write plus or minus in this unit because, again, we're just talking about lengths. And so our x value, when I take the square root of 400, I take a look at the positive value, and it's 20. So I found out my x using property 3. All right, let's see here. Next up, let's go with example 3. I don't know if I'm going to be able to do all these. All right, so we're going to get into using properties 2 a little bit more. All right, so let's see here. Example 3. So again, these two triangles are similar. I'm going to say that already. Find x and y. All right, so these two triangles, again, are similar. So I'm going to draw my triangle here. We have triangle A, B, and C. And again, here's our triangle D, E, and F. Now, I know some sides here. I have an X, a 4, and a 7. All right, and on this side, I have a 15, a Y, and a 21. And I want to find X and Y. So I know I don't know anything about the angles, and I don't know anything about the areas. So I'm not going to use both property 1 and property 3, right? I don't know anything about those. But property number 2 is all about the sides. All right, now, if these triangles are similar, which I said they are, it means the ratio of the sides, matching sides, are equal. Now, when I look, so I'm going to try to solve for x first, all right? Now, what I need here in this situation is to actually know the ratio of matching sides. And there is one side where I know both lengths, and that's from B to C and E to F. All right, so I'm going to have my triangle on the left is on the top for my ratio, divided by the triangle on the bottom. Now, I know because they're similar that that ratio is equal to all the ratios of the matching sides. So if I'm trying to find x, I'm going to compare it to 15 over here. Now again, with my ratio here, I did the triangle on the left on the top. So I'm going to put the x on the top, and I'm going to put the matching side on the bottom. So now I've made those two matching side ratios equal. Guess what we got? Fraction equaling a fraction. Surprise, surprise. It's going to happen a ton this unit. All right, so again, to simplify it, I'm going to cross multiply. So I'm going to go 21 times x is equal to 7 times 15. All right, so that's 21 times x is equal to 7 times 15, which I'm not sure what it is. Let's see here, 21 x, and let's see here, 7 times 15. It's 105. Whoops, 105. And of course, I'm going to divide both sides by 21 to get x by itself. And so I take 105 divided by 21, and I find out that x is 5. All right, now I'm going to use the same method to find y. All right, so again, here's the side ratio where I actually know the value, right? The 7 and the 21. So I'm now going to use that ratio again, but this time to find the y. Now the y is over here, and it matches up with the 4. Again, I got to make sure that I have the right side put in the right spot. Now this triangle on the left, I've already said I'm going to put on the top. So I'm going to put the 4 on the top this time. And because the y is on the triangle on the right, it's going in the bottom. Fraction equaling a fraction. I'm going to cross multiply again. So this time I have 7 times y is equal to 21 times 4. All right, now that means that 7 times y is equal to 21 times 4. That's 84. All right, and then getting y by itself, I'm going to divide both sides by 7. And 81 or 84 divided by 7. I don't know if that's how that number looks. 84 divided by 7, we get 12. And there we go. So that's how we're finding missing side lengths. All right, I'm going to try one more of those. I'm going to skip over here to example number 5. That's on my sheet, if you're following along. All right, so example number 5. All right, talks about 2 people are on the same side of a river. Good for them. All right, so I'm going to draw a little river in here. There we go. So they take measurements to calculate the width of the river. Examine the diagram and find the width of the river. All right, so I'm going to say that there is a rock right here, and we're going to look at the width of your river. So there's our W right there. And let's see here. I'm going to say that, make sure I draw this correctly. There we go. So there's my 2 triangles. I know this distance here is 18.6. I have 3.8 right here. They take measurements that this is 7.2 in there. And let's see here. That's it. That's all I know. All right. So now this has got 2 triangles here. The big one right here and the little one up here. And what I need to be able to figure out is which sides match up. All right. Now, this triangles, before I had them, like you can see them lined up, but this one's, they're kind of flipped. And so if I look at my angles here, I'm going to say my red angles here, they're the same. These 2 angles right in here, this one here and this one here, are the same because opposite angle theorem from grade 9 math. And so if those 2 are the same and those 2 are the same, well, then our third one must be the same. So I'm going to put that in blue. So now, because I can match up the angles, I can match up the sides. Because I know now that from the red angle to the blue angle, those two sides are equal. And so, let's see, I'm going to do my big triangle on the top. So I'm going to have a W on the top. The matching side, again, from red angle to blue angle, is 3.8. Now, from red angle to green angle is 18.6. Now, that's my big triangle, so that's going to be on the top. And then, of course, the last angle I'm looking at is the 18.6. Again, the green angle to the red angle, which is a 7.2. And there, now I've set up my equation using the fact that in similar triangles, matching side ratios are equal. Again, I have a fraction equaling a fraction. I'm going to cross multiply and solve. All right? So I'm going to have a 7.2 times a W. Then I also have a 3.8 times 18.6. All right. Again, just simplifying. Ooh, I got some decimals there. So I got 7.2 times W. I'm going to multiply those two numbers. Let's see here. 3.8 times 18.6. We get 70.68. All right. And of course, the last step is to divide by my numerical coefficient here of 7.2 on each side. And so I can figure out that the width of the river is 9.82. I guess we're going to call it meters in this case. There we go. Throw some units in there. 9.82 meters. So there we go. There's similar triangles. All right. Later on today, or I won't even say later on, very shortly, we are going to be looking